Hello and welcome to College Algebra Review for Chapter 7 with Equations and Inequalities. So in this video we're going to be looking at a few problems. This will be geared towards a review of the typical questions you'll see in a chapter involving equations and inequalities. Let's begin. Okay, we start off with number one. We're finding the distance between 2 points and we're expressing the result in simplest radical form. So here we see on the screen the distance formula. Okay, so we're going to use our points and just plug in to see what the distance is between the 2 points. Okay, now if it helps you, you can label your points. Your first point, you can label it as x1, y1. Your second point would be x2, y2. When we plug in, keep track of your negative signs, okay, with the minus signs, because they do make a big difference. Okay, so let's just begin. Very straight up, easy question. Just set up your square root. Subtracting our x's, we have x2 minus x1, so that is 1 minus negative 1 squared plus 2 minus 4 squared. Okay, once we plug it in, simplify your parentheses. So we have a square root. 1 minus negative 1, we have a double negative. So that'll be a plus positive. 1 plus 1 would be 2. So that's 2 squared. Plus 2 minus 4. So 2 minus 4 is negative 2. And that we will square. So in the next step, let's square each of these. 2 squared. 2 times 2 is 4. Negative 2 squared, so negative 2 times negative 2. Negative times negative is a positive. So that's 4. Add them together. 4 plus 4 is 8. Okay, and they want the result in simplest radical form. Okay, so square root of 8, we know we could rewrite that as square root of 4 times 2, which we say is the square root of 4 times the square root of 2. And we can take the square root of 4, that's our perfect square factor, right? Square root of 4 becomes 2. And so we're left with 2 root 2. Okay, so anytime you do one of these distance formula problems, just make sure at the very end to simplify the radical, as best as possible. Okay, let's move on to number 2. In number 2, we want to find the equation of the line that contains negative 3, 6 and 3, 4, and we want to express the final equation in standard form. Okay, so a lot going on here. Okay, we need to figure out the slope, right? Then we need to figure out what the y-intercept is, and then from there we could go on and convert it to a standard form problem. Okay, so you see on the screen we have the slope formula, we have the point slope form, which will help us, we have the slope intercept form, and then finally we have the standard form formula. Okay, now one thing to note about standard form, when it's in this form, a, b, and c, these are integers, and a is greater than 0. Okay, that's the criteria for standard form. Okay, so let's start off by first finding the slope. Again, if it helps you, you can mark off your points. You have x1, y1, x2, y2. Okay, and let's plug in to figure out our slope. So y2 minus y1, so we have 4 minus 6. x2 minus x1, 3 minus negative 3. Okay, that gives us negative 2 on top. minus a negative is plus positive, so 3 plus 3 is 6, and we can always reduce the negative 2 over 6, which gives us negative 1/3. Okay, so slope is negative 1/3. Next step, we're going to try to figure out what the equation would be in slope-intercept form. Okay, so we could use either the point-slope form or the slope-intercept form for this. Using the point-slope form, we'll get the equation directly. Using slope-intercept form, we'll get the b, and then from there we write the equation. Okay, and then we'll do a little converting at the end to get standard form. Okay, so let's begin. Now we have a luxury. In this case, we have 2 points. We're going to pick one of them. Okay, it doesn't matter which one you pick. A lot of people will avoid the negatives. So if you have any negatives, you might want to try to avoid that. Okay, so I'm going to pick 3, 4. Okay, so that 3, 4, that'll act as my x1, y1. Okay, and what I could do after this one, I'll show you a secondary version. Like instead of using the point slope, I could show you how to get the same result with the y equals mx plus b. Okay, and then you guys could decide which way you want to go. Okay, so starting with the point slope form, we have y minus y1. So y1, that'll act as our 4. It's y2, but that was for slope. So we have 3, 4. So y minus 4 equals negative 1/3, that's our slope, times x minus x1. x1 is going to be our 3. Okay, next, let's simplify this down a little bit. We have a negative 1/3, we'll distribute. So negative 1/3 x. Negative times negative is a positive. 1/3 times 3 is 1. Okay, and then next step, add the 4. So y equals negative 1/3 x plus 5. Okay, so in order to convert this to standard form, remember one of the criterias was we cannot have any fractions or decimals, right? We have a fraction here. To undo that fraction, we can multiply by its denominator. Okay, so I'm going to multiply everything by 3. Okay, so we end up with, 3y equals, now distribute the 3. 3 times negative 1/3, that's just negative x. 3 times 5 is 15. Okay, and then last step, we're going to move the x to the left side. So we'll just add x and add x. Okay, so we'll end up with x plus 3y equals 15. Okay, and that'll be our equation in standard form. Okay, so let's do the same thing now with just the y equals mx plus b form. Okay, so we did the slope already, so picture that part. We did the slope. And now let's just focus in on the y equals mx plus b version. Okay, again, you're going to pick one of the 2 points. If you want this time, let's pick the one with the negative. Yeah, let's pick the negative 3 and the 6. Okay, so we have a slope already. We have an x and a y. Okay, and now let's just plug into the formula and we can solve for b. Okay, so we have the 6 is our y. So remember, we're going to plug into our y equals mx plus b. So 6 is y. M is negative 1/3. X is negative 3 plus b. Okay, now the next step is just we're going to just multiply negative 1/3 times negative 3. So we have 6. Sorry, I don't know why this is doing that, but we have 6 equal to negative 1/3 times negative 3. Okay, negatives will cancel, be positive, just 1. Okay, so we have 1 plus b. Now to get the b by itself, subtract 1 both sides. So b equals 5. So what's our equation now? Okay, we could write it in slope-intercept form to begin with. Y equals the slope, negative 1/3 x. And then the y-intercept is 5, so plus 5. Okay, and again, we're going to try to get rid of the fractions. So multiply everything by the denominator of the fraction is 3. So multiply by 3. So we have 3y equals negative x plus 15. Bring the x to the left. So we have x plus 3y equals 15. Okay, and notice that's the same as we had before. Okay, so you could use either version. Just remember, first step, figure out the slope, and then use either the point slope form or slope intercept form, and then from there, do the conversion for the standard form. Okay, let's go on to the next one. Graph linear equation by finding the x and y intercepts. Okay, so remember for x and y intercepts, to get each intercept, the opposite variable will be 0. Okay, so for example, getting an x-intercept means make sure the y is equal to 0. To get a y-intercept means x is equal to 0. Okay, and you just solve for the variable. Okay, so x-intercept, okay, y is 0. So what you could do is take your equation, just cover up your y, or you just replace it with 0. Okay, so we have 3x minus 2 times 0 equals 12. Okay, so basically when I say cover up, just, 2 times 0 is 0, and that doesn't do anything to the problem. So you have 3x equals 12 divided by 3, so x equals 4. Okay, so that means at 4, 0, we have our x-intercept. Our y-intercept, now this time you're going to replace the x with 0. Okay, so we'll have 3 times 0 minus 2y equals 12. And again, what I would do is cover it up. We know that 3 times 0 is 0, and it adds nothing to the problem. Okay, so we basically have negative 2y equals 12 divided by negative 2. So y equals negative 6. Okay, so that means 0, comma, negative 6 would be our y-intercept. Okay, let's graph the two equations, the 2 points, I should say. So we have 4, 0, and 0, negative 6. Okay, and then once they're graphed, now just use your line, connect them. In fact, we can do this, just draw a straight line going through the 2 points. Okay, and then we could just put arrows at the ends to tell us the line will go infinitely in those two directions. All right, so that is our graph. Okay, next one. Let's take a look at graphing an inequality. 3x plus 2y is less than 6. Okay, similar approach to graphing the equation version, 3x plus 2y equals 6. Okay, one of the things to remember with inequalities, if you have a less than or greater than, you'll have a dotted or dashed line. If you have a less than or equal to or greater than or equal to, you'll have a solid line. Okay, this one is just a plain less than, so we have to remember to draw a dotted line when it comes to the line. Okay, once you draw the line, remember the additional part to this is the shading. Okay, so you want to make sure you do the shading, and we'll get to that. We'll talk about that. Okay, so we could do this with our intercept method, just like we did with the previous problem. Okay, so let's get the x-intercept. Let's get the y-intercept. So x-intercept, remember y is equal to 0. Okay, so if we cover up the y, that means we have 3x equals 6 divided by 3, so x equals 2. So x-intercept is 2, 0. Y-intercept, remember x is 0, so that means we cover up the x, so we have 2y equals 6 divided by 2, so y equals 3. So that means at 0, 3, we have our y-intercept. Okay, so let's graph them. So we have 2, 0, 0, 3. Okay, this will be a dotted line. Didn't like that one. Let's try that one again. Okay, and so once we have it graphed, just extend it this way. The next part is we want to test a point. Okay, testing a point is going to help us determine which way we want to shade. Okay, so at this juncture, we're going to either shade going below this line or above the line. Okay, so testing a point will help us to figure out which way to shade. Easiest point to test if the line is not going through the point would be 0, 0. Okay, 0, 0 is a nice easy point to test. Okay, so what that means is we're going to plug in 0 and 0 into our inequality. So 3x plus 2y is less than 6. Okay, so 3 plug in 0 plus 2 plug in 0 is less than 6. Okay, is that a true statement? Let's figure this out. Well, we know anything times 0 is 0, right? 3 times 0 is 0. 2 times 0 is 0. 0 plus 0 is 0. Now ask yourself the question, is 0 less than 6? It is, correct? And so the test area, right, was the test area. So that 0, 0 is a representative of a point on this left side. Okay, and because it turned out true, we end up shading that side. Okay, so that side gets shaded. Okay, the question now is what happened if that was a false, right? If that turned out false. Well, if that turns out false, that means we would have to shade the other side. Okay, so that's how that works. Okay, let's practice another one of these so we get the hang of it. Okay, graph the inequality. X minus 4y is greater than or equal to 8. Okay, and like we did the other ones, we're going to graph x minus 4y equal to 8. Okay, now the line for this one, we see it's a greater than or equal to. Okay, so that means we'll have a solid line. All right, so solid line. Okay, so again, we could do x-intercept and y-intercept. Okay, remember, x-intercept means y is equal to 0. Y-intercept means x is equal to 0. Let's do it. Okay, so if the y is equal to 0, that's gone, so we just have x equals 8. Okay, so that was quick. So 8, 0. For the y-intercept, x is equal to 0, so that means we have negative 4y equals 8. We could solve this by dividing by negative 4, so y equals negative 2. Okay, so 0, negative 2 will be our y-intercept. Okay, so let's graph it. We have 8, 0, 0, negative 2. Okay, we know it's going to be a solid line. Okay, and once we have it graphed, let's see if we can adjust ever so slightly. Okay, so and then we're going to test the point. Okay, so again, we could test 0, 0. It's not on the line, so test 0, 0. So let's plug it in. 0 minus 4 times 0 is greater than or equal to 8. That gives us 0 minus 0 is greater than or equal to 8, which simplifies to 0 greater than or equal to 8. Okay, is that true? Is 0 greater than or equal to 8? No. Okay, so what does that mean? 0, 0 was here, so we're not going to shade that side, right? We're not going to shade above. That means we're going to shade below. Okay, so all this gets shaded. Keep in mind, you can plug in other test points. You don't have to always plug in 0, 0. Okay, you could plug in, as long as it's not on the line. Okay, for example, you could plug in 5, negative 3. Okay, and then that should turn out to be a true inequality at that point, right? Because 5, negative 3 is in the shaded region. Okay, so let's do that real quick. Let's test 5, negative 3. Okay, so that means we have 5 minus 4 times negative 3, and we're checking if that's greater than or equal to 8. Okay, so we have 5. Negative 4 times negative 3 is a positive 12. 5 plus 12 is 17. 17 is greater than or equal to 8. Okay, and that is true. 17 is greater than or equal to 8. And it shows us that what we did is correct, right? That side is the shaded side, and so we're done. Okay, let's take a look at our next one. Write the equation on a line that contains the point 4, negative 5 and is parallel to the line 8x plus 2y equals 12. Express the answer in standard form. Okay, so remember for parallel, right, the concept of parallel, many of you will remember that parallel lines mean we have the same slope, right? So parallel is synonymous with the same slope. So whatever the slope of this line is, right, we're going to use that slope, and that'll help us to figure out what the equation will be. Okay, so let's rewrite this equation in slope-intercept form, and that'll allow us to extract the slope, right? That'll get us the slope for this problem. All right, so let's check it out. 8x plus 2y equals 12. We'll convert this into slope-intercept form. So minus 8x to both sides. 2y equals negative 8x plus 12. Divide everything by 2. So y equals negative 4x plus 6. Okay, what's the slope? Right, slope is negative 4. And we have our point for negative 5. And so now we could go into our finding the equation mode, right? So we're trying to find the equation of the line that goes through 4, negative 5, and has a slope of negative 4. Okay, so let's do that. We could use our point slope form. So y minus y1, so we have negative 5 equals slope negative 4, x minus x1, which is 4. Okay, double negative, be careful there. So that's a plus positive. So y plus 5. Distribute here the negative 4. Negative 4 times x. Negative 4x. Negative 4 times negative 4 is a positive 16. Okay, minus the 5. Y equals negative 4x plus 11. Okay, and they want standard form. Okay, so be careful there. We can add the 4x to both sides. And so we have 4x plus y equals 11. Okay, and that would be our final answer. Let's take a look at our next one. Right, the equation of the line that is perpendicular to the line 3x minus 4y equals 8 and contains the point 3, 5 standard form. Okay, so perpendicular, remember perpendicular is synonymous with the two slopes have to be negative reciprocals of one another. Right, so slopes are negative reciprocals of one another. Another way a lot of textbooks will express this is they'll say m1 times m2 equals negative 1. Okay, and that serves the same purpose, right? Slopes are negative reciprocals of one another. Okay, so in order to get the negative reciprocal, let's get the slope of this line. Let's figure out what it is, and then we'll talk about what the negative reciprocal would be of that slope. Okay, so we have 3x minus 4y equals 8. Okay, let's put it in slope-intercept form. So we can minus the 3x both sides. So we have negative 4y equals negative 3x plus 8. Divide everything by negative 4. So we have y equals two negatives here. Negative divided by negative, so that's positive 3/4 x. Positive divided by negative is negative. So y equals 3/4 x minus 2. Okay, so we know what the slope is now. Now we just have to focus on what's the perpendicular slope. All right, so perpendicular slope, that would be the negative reciprocal of this one, right? So we have 3/4. Reciprocal means we're going to flip, right? Just flip this upside down. So 3/4 becomes 4/3. And then if this 3/4 is positive, our perpendicular slope will be negative. Okay, so the way it works is if one of the slopes is a positive, other one will be negative. Okay, just to double check, we have 3/4 times negative 4/3, and we get negative 12/12, which is negative 1. Okay, so we have our slope now. Okay, so that's our slope. We have our point from the problem, 3, -5, and now we could solve for our line. Okay, I'll use the slope-intercept form version for this one. So I know my y is 5 equals m. My m is negative 4/3. My x is 3 plus b. Okay, simplify. Negative 4/3 times 3. We can just cancel the 3's. So we have negative 4 plus b. Again, move the 4, the negative 4, so plus 4. So we have 9 equals b. Okay, so that's our y-intercept. So now the equation will be y equals negative 4/3 x plus 9. Okay, now remember one of the things we did earlier? We multiplied by the denominator to cancel, right? Because we're going to go into standard form. We don't want any fractions. So multiply everything through by 3. Everything. So we have 3y equals, now the 3 there would cancel, so we have negative 4x, and then 3 times 9 is 27. Okay, bring the 4x, the negative 4x to the left, so plus 4x, plus 4x, so we have 4x plus 3y equals 27. And so that would be our equation in standard form. Okay, so I hope this helps. Feel free to pause each problem and try it, and then compare your answer to the answers you're seeing. Okay, I hope this helps, and I hope you guys enjoyed the video and it is of some help to you. Okay, have a good day. Have a good night. We'll see you soon.